thank you. Thanks for everyone attending session after the break. Hopefully everyone got some snacks. Cool stuff going on today. It's been a pretty awesome conference so far. I was last minute tweaking my Docker containers, which everyone likes to do right before you get on stage. Always fun. My talk is building a real-time IoT application with a bunch of open source. Obviously, Pinot is a destination for that. And I'm going to cover a lot of streaming. If there's parts people are more interested in, definitely acknowledge. I'm going to try to leave a decent amount of time for questions. It seems people may have some questions on where'd you get that jacket? How does that involve IoT? All those kind of things. We will get to that. Now, I have a full article on this and a full repo. We did a trial run of this last year in New York City as part of a joint Pinot and Pulsar meetup. And there's a recording of that because that demo went really well because we didn't have a lot of people there. The more people you get, the less well demos go. So we'll see what happens. I do what I call the flippin' stack or flank stack, depending on the streaming tool of the month, whatever it is, covering everything streaming, whether it's from the on-ramp with things like Apache NiFi to what's in the middle with Kafka and Pulsar to stream processing with Flink, and sometimes write that in code with Java. I run a bunch of meetups in person on the East Coast and often hybrid, record them. If people are interested in attending or speaking, definitely come to the front after the event. We'll get in touch. Doesn't matter what time zone you're in, as long as you don't mind, speaking virtually in the afternoon. I got a big event coming up in a couple of weeks where we're going to show some of the new stuff happening with NiFi. And at the end of it, we're going to have a hackathon. I would love to see someone doing NiFi with Pulsar, NiFi with Iceberg, NiFi with Pinot. There's definitely some things that could be built, and the winner gets a nice prize, and we put that in we'll put it in a blog, and we'll build a pre-available flow so everyone can grab it and start using it, which is pretty cool. Just to go through quickly, I'm going to cover, and I can tell you too much about Pinot. If you don't know anything about Pinot, you snuck in, and you should leave, because hopefully by now you've got an idea what Pinot is. I'm going to cover Pulsar a bit for my friends in the booth over there. Pulsar is a pretty interesting project. I'm going to cover NiFi to Pulsar to Pinot. I'll do the same thing with Kafka, and I'll show you some other stuff. These are my cats. These are not, AI-generated cats. It was very hard to get those ties on. Cats and ties don't go well together. So there's a lot of different assets we'll cover. Those are all in the GitHub. So if I go too fast because I'm trying to, you guys didn't start the timer. So I don't know what time it is. Unless I was supposed to start that. I was probably supposed to start that. Yay, thank you. NiFi is consuming all the data. That's why I wore my nice jacket. People said I should have wore the matching pants. We'll do that next time. Sorry about that. So Pulsar, what's Pulsar? If you've heard of Kafka, it's kind of like the sequel. It unifies messaging so you could do lots of different types, which is pretty awesome. Guarantee you'll always get your message. That's really important because, if I send a message, I probably want to get it. It's not like the mail where, maybe you lose it for 40 years and I get it later. No, we don't lose it. Very resilient, very scalable. You throw around words like infinitely scalable. It's not a joke. People in China are to thousands, tens of thousands of nodes, petabytes of data, as big as you can afford size. For me, that's my laptop, so it's pretty small. What's cool is you can write your consumers and producers in different languages, use different protocols. This makes it really nice if you're trying to move stuff between different environments, legacy systems. So being able to take something that's talking Kafka and unchanged, maybe just change your router to point to the Pulsar server instead, talks that Kafka protocol, Same thing with your legacy AMQP, Rabbit, MQTT, or if you've written it fresh in Pulsar, all go in, touch the same topics if you want, and then come out the other end. It doesn't have to be the same protocol going out. So I could have Kafka in, Pulsar out. I could multiplex it, so Kafka comes in and then Kafka, Pulsar, and Rabbit come out WebSockets, REST. And I could do it in a streaming paradigm, so it looks like Kafka, or it could come out like messages, where you could do work queues, traditional microservices. Kind of nice way to integrate data there. And what's cool is when you say multiple protocol support, you think, well, maybe someone put a sidecar over here, someone threw together a proxy, maybe there's some weird translation layer that kind of attempts to translate it. That's not the case. They took the full library, the full protocol, implemented that as a handler, and it's a first-class system in Pulsar. If you want really in-depth stuff, we've got a committer in the front row here if you want to harass him later. So that's really cool is it's not, you're not using something that maybe works, maybe doesn't work. Full library support, everything you need to do there, very cool. Same thing with MQTT, which is great for IoT. So now I don't need to run a separate MQTT broker somewhere, which is great for all these IoT use cases where you have lots of devices in the field. They often talk MQTT, and then you've got to have somebody else ingest that, translate it, and then send it out maybe Kafka or send it out some other protocol. Here I could send those MQTT calls from devices right into Pulsar, no translation, and can start streaming right away. And because Pulsar runs pretty lean, you could run this on a gateway that's right near to something. Think of in the back of a truck, in a warehouse, and being able to do that right away. Really nice way to get data onboarded. If you've got a lot of legacy Rabbit apps, another option there. This is the only cat in the slide deck. It's not my cat. But data and cat together, I could not resist that. So streaming, a lot of things. If you were at my event yesterday talking about streaming, it's a lot of things to a lot of people, and that could be a 9-hour debate. But really, to me, is ingest some data, distribute it with some transformations, enrich it, and then get it somewhere. There's a lot of somewheres to get it to. And most people don't have just one. It'd be nice if we just ran in our magical kingdom of NiFi, Pulsar, Flink, and Pinot and didn't need anything else. But none of us work in there. Not even my laptop works in that magical realm. We tend to have a ton of different stuff for different use cases depending on what we need to do. And I'll zip through some of these. I'm not going to mention too much about Kafka. Oh, I only had one slide. That's about all you need to know about Kafka. If you haven't heard of it, you probably missed that boat and just go to Pulsar. If you want a free environment to play with and run on your laptop, as long as you got a decent amount of RAM, there's a Docker open source package of libraries that all run together really well. One Docker Compose. I'm actually using the Zookeeper from this to run Pinot, which is probably ill-advised at this point as I've figured that out, because trying to keep Zookeeper clean, yes, at some point, please get rid of Zookeeper. It would be nice to not have it anymore, but a number of our projects out there still need it. It works really well. It really doesn't crash, but it's a little quirky. So NiFi is kind of my best friend. If you saw me yesterday or the day before, I was wearing the NiFi shirt. I'm wearing the hometown shirt today. NiFi is really cool, and I'll show you that because what's interesting is not just a scalable tool, it is WYSIWYG. I drag and drop components and just grab what I want real time, move things around, pretty cool. Lots of different sources and syncs. We still got to work on one for Pinot natively. Right now we push it to either Kafka or Pulsar, which have nice ingest into Pinot. Maybe that's the best way to do it. We'll see when you're other APIs come out, see which one's better. I kind of like to have Kafka or Pulsar act as the funnel to downstream data sources, though adding an extra hop, there's the debate there. We'll have to see. We kind of showed that slide before. This is my cat, Stormy. This is a big cat. NiFi is really cool. I think we showed that one already. There's a connector for Pulsar, thanks to the guy in the front row. If you don't like it, you could harass him. Flink SQL, another good part of building these pipelines, because this part is critical to me, is very often I don't want to just have one stream of IoT go right into something like Pinot. I'm doing that in the demo because it's all running on a laptop. But when you get into the real world, I have a client with 27,000 devices at each location. So I don't want 27,000 individual streams going into 27,000 tables, or all of them hitting the same table, maybe out of sync. That might cause some problems, or might just not get the results you want. So I use something like Flink SQL, and there's some other alternatives out there for some cloud vendors. This lets you join together those streams, aggregate them, and do it fast enough that it really is not, not something slowing you down. This is fast enough that credit card people use this. This is used by Alibaba at scale. Flink is fast, and Flink is very scalable. So having it sit there waiting on a Kafka topic or Pulsar topic and joining together different streams, doing aggregates. Because if I have 20, 30,000 devices, I probably don't need every record. Maybe I want, averages over 5 minutes or 10 minutes. Maybe I want things that just look out of place. Something's not performing right, something's too hot, something's too large of a value. And those are the ones that I need to immediately send somewhere to be acted upon, like shut down this tire, stop this wheel on the train so it doesn't overheat. Those kind of things that need to happen right away. This is a great place for that. And then on the other end of this, we push out maybe as a aggregated Kafka topic, and that might be the one that makes the most sense to go right to Pinot, and then you're doing your analytics then. But this is, 1 minute later. So it's not like, this is batch or legacy, maybe less, maybe it's a second later, depending on how much data and how big your infrastructure is. And the SQL is rich. It's pretty standard ANSI SQL 92 with a couple of add-ons, and there's a working group that I heard about last night that they're working on standardizing streaming SQL, because a couple of different people have some different ideas what should be in there. But you could do union. Everything you've done in SQL before is still there. Group by and having and joins and unions and minus, outer joins. Some of them are a little weird in some contexts. Sometimes we'll use this to join between a live stream and something on a data store like Iceberg table. And maybe at some point it'll make sense to join with a live Pinot table. I don't know if the Flink group is working on that yet. That would be a cool project to see, being able to join those two different data sources, especially if you're doing lookups and you do them pretty quickly, which would be nice. I've got a tool that does some of that Flink SQL with a little bit of, makes it a little easier. If you started off a data engineer or a coder, you put this all together at the end. Once you're a streaming engineer, you've reached enlightenment and can build pretty much anything. My default example, which is in GitHub, if you want to try it, is I've got a sensor on a device which really couldn't get on this network here. It worked in my office in San Francisco, but did not work here. So I have some of that data backed up to rerun it, but went from the device, went into Pulsar. Once it landed in a Pulsar topic, each event got pulled into Pinot, and I'll show you how you connect Pinot to Pulsar. It's the same way as if you've done the Kafka streaming ingest. It's just you change out a couple of the parameters, and instead of saying Kafka, it's Pinot. As of right now with the project, it does require that you manually compile that connector and add that into your cluster, which is a little extra work, but you know, not super hard. Once we landed into Pinot, we could do analytics with Superset really easy. And because it's in something like Pulsar or Kafka, really easy to ingest it with other tools and do other things. Like do some Flink SQL on that as it's coming in, maybe doing aggregates, max, min, looking for alert conditions before you start doing your full analytics there. And then part of that is sending that data to Apache NiFi to do some enrichment and transformation. Again, I could have had NiFi send the data to the topic and eventually NiFi right into Pinot, waiting to figure out what connector there. Sometimes it's hard to tell where the data should go. Because of that really nice connector between Pulsar and Pinot, it makes sense to get it into those topics as soon as possible so that it could get streamed out into your Pinot real-time tables. Pretty straightforward. I have some screenshots here in case things remain crashed. Parts of the demo have been a little stressed as I've running on this one laptop in Docker, Flink, Kafka, Pulsar, Pinot, NiFi, and 7 other tools, and Google Chrome, which is probably the heaviest of all of them. I wish I had a server to run Google Chrome separately up from my laptop. But this is the setup. It's pretty easy to set up these tables to get the data from IoT. You set up a schema, which you can have auto-generated based on your data. And I'll walk through the GitHub for that. I was impressed how easy it is to set up those schemas. It probably should be a GUI that auto does that instead of having to run a little app, but you know, that's picking hairs. It's a very easy process, and setting up a table is setting up a couple of parameters you got to decide on. Once you have your table, getting data in is really easy, and then you could use it, you know, for whatever purposes you have. I'm just showing these screens in case my other ones don't work. And then connecting Pinot to Superset, very easy. Lets you create charts even if you don't know how to create charts. It's pretty straightforward. I couldn't figure out too good of charts to show, but just some tables and some different values. So the way we start doing this is using the infer schema JSON data. This part of a recipe lets you look at a example JSON record and build your schema. I've got some more links there to make it easy. If you have a clean machine with no other Docker things running, this is very easy to set up from their pinot-pulsar Docker composer. The one thing I'll tell you is don't try to use Zookeeper with several projects running at once, because Pinot likes to write a lot of metadata to Zookeeper, and then if you restart it, it'll write another set. And if you have 3 servers running on there, but 2 of them really aren't running anymore, and they're in Docker, things get weird. But this is really the main thing you have to set up, is you have your JSON data, figure out what fields you want for metrics, give it the dimensions you want, and it'll build the schema for you. And then if you want to manually tweak it, you can, but this seemed to work out pretty well. And then you add your schema to your Pinot pretty easily. And then for me, I screwed it up a couple times, so I deleted it. You could either delete it with the Swagger UI, or if you've got a StarTree UI. The default open source UI is a little iffy on deleting tables. Kind of works sometimes. This might be, maybe there's a newer version. I got to try that out. I didn't get to sit in that session. Once you delete the table, delete the schema, then you could re-add things, make sure they're stable, pretty easy. And I'll go into the NiFi code here, just in case everything didn't work. And as a second demo, which is no way I'm going to have that running successfully on the laptop, just do the same thing with Kafka. Kafka has a similar connector for Pinot, but that'll give you an idea. I'll probably do that as an article in a week or two, if enough people are interested. There's already examples. Confluence put a couple out for connecting Kafka and Pinot. It's pretty easy. I'm going to get to the code, but I want to make sure I finish these slides, because once I get past the slides, I can't use this cool clicker anymore. This one reaches from, I think this will reach from the bathroom. They have a really good clicker here. Let's see if things are still working here. Yeah, seems to be working. This is Apache NiFi. Again, drag and drop environment. Now, I should be getting all this data from the Pulsar topic to do some extra work. So that data came off the device, went into the Pulsar topic. Now that device is not sitting next to me here because trying to get it on the internet was not happy. So instead I've got some data that I backed up, and I'm just going to pull that in and slowly trickle that into the system. The nice thing with NiFi is it's pretty easy to create data simulators or grab things from files. Don't really care where the data comes from. You know, I could just send any data anywhere, any way I want. What I'm showing you now is a pretty unique feature of NiFi that comes in handy when you're trying to figure out what went wrong, which I'm sure for nobody else, nothing ever goes wrong on any of the apps you're writing, everything just smooth. But for me, to figure out what happened, within NiFi we have this provenance data that tells me every step of the way what's going on with my data, unique name on it so I could track it, the file size, where it was, who touched it, how they touched it, what happened, where it came from, and then I could get to the actual data. Like here, this was the JSON data. Is that pretty big? Yes, that's pretty big. And that's the data coming off the device. As you can see, this one's a little older. That had the CO levels, humidity. So just some standard sensor data in a JSON format. But if this was damaged, I could see that here at that step. And I could see it made it to Pulsar. If that was coming out a different step, I can check inside the provenance at a different spot and see what happened. Okay, it ran it here. Is it the same size, same ID? I can also pause the data live as it's happening. I could restart things, start and stop them on demand very easily. Like here, I stop things so when it gets into Pulsar and when I pull it out, I can walk through things iteratively while I'm coding and change them on the fly based on what I want to do. So if I see this data here, I have 5 records. Okay, do I want to do something different with this particular row based on what's coming in? If I wanted to, I could drag that and send it somewhere else. Say I wanted to send it to a different data store temporarily, because maybe I lost all my network connections. So maybe I just push it in a file. I could just grab that, create the new one, grab that live connection and move it somewhere else. And then if I set the settings in here, now it's going to write there instead of where it was before. Or I could just move it back, restart this one, and not lose any data, have data in the same order, same features. Pretty cool when you're trying to build things or configure them or figure out what's going wrong with things. I could also do things like put dynamic back pressure on each one of those connections, where there's also an algorithm if you want to calculate that on the fly. I could also load balance. Obviously, I'm not load balancing on my laptop. I have 1 node. But if I'm running this in a real environment, maybe I have 10 nodes, 30 nodes. And this could round robin data around. So you spread the workload so it's not too much work. What's nice is I have full control over that. So if there's some things I want to stay on a node, or if I want them to stay in a certain order, I could do that. If I want them to be distributed, I could put priority. Lots of interesting things you could do there. So theoretically, the data got into Pulsar, and then the next step is Pinot. Now right now, I lost my server there, so that makes it a little difficult for it to arrive. But what happens is I have a schema set up. Once you have the schema set up, you're in a good space. Then you can create your table. My table is still crashed, which is perfect timing because it was set up and working fine before, but it's very easy to set up the table. I've got all the code in here if you want to give it a try. Now to create a table, pretty straightforward. Add that configuration, and we just have the JSON here. I have links to the official Pinot documentation. You want to give it a try. And the table is pretty easy to write these. This is, pretty straightforward. For connecting to Pulsar, you got to make sure you use the Pulsar keyword, connect it to whatever your topic is, connect it to your servers, and then the rest is default. The only thing you might change is where you're doing your offset reset and maybe some of the thresholds. Other than that, these are pretty generic for doing real-time tables, other than setting your time columns, number of replicas. Other than that, this will just set you up to get your data streaming into Pinot. And once you have it into Pinot, everyone in here knows what you could do. Pretty straightforward, but gives you all the capabilities you want. I've got some other pieces in here if things didn't time out. Otherwise, we'll start doing questions. Maybe I'll ask for questions before I start showing other stuff. Anyone has questions before we do some more demo? No questions. Too easy here. Too easy? Okay. We got to show some less easy stuff perhaps. Let me log into my cloud stuff. The good thing with that is if that crashes, somebody's losing money, so someone's yelling at somebody. Here, I'm the only one to yell at myself for not getting my Docker working well. But sometimes the network capabilities here are not the best. Has the internet been great for people here? Everyone but me? Thanks. Thanks, guys. You took up all the internet. Could have saved some for the rest of us. Okay. So this is another edition of running NiFi in the cloud on top of Kubernetes without running a server. Part of the problem with running something like Apache NiFi is setting up the server, setting up security, setting up connections, and then scaling it out. So instead, you could use a Kubernetes that's hosted in the public cloud, design your flows here pretty easy, set up all your parameters so that I could set this up to be deployed on demand wherever I need it to go and scale up automatically. So it makes it pretty easy to get your data running, and I could still test it while I'm developing it. And once it's ready to go, I can deploy it. And deploying is pretty straightforward. I could take the flow that I have right now, publish it to my catalog. Once it's in the catalog, it's ready to be deployed. Here I have one that I paused just because I didn't want to spend that cloud spend when I wasn't using it. And I could just redeploy it, and I could decide, do I want to add any kind of things that I want to track? Like I can track every component in the flow independently to see if it's using too many resources and then create an alert. If too many messages are failing, then maybe I want to trigger an alert if it's over something and do it every couple minutes. So when I deploy that, I'll have some KPIs. I could decide how I want to size it, how many nodes I want to expand out to when I'm deploying it. Pretty straightforward. But if you want to do start a flow, it's pretty nice way to do that. I don't know if I'm going to wait and watch that happen. Another thing we had running, as I mentioned, was the Flink. Here is very straightforward. I'm just running a query on that on a Kafka topic which could also be a pulsar topic based on data as it's coming into the system. Pretty straightforward. So for here, I'm just going to start that running again. I have to pause it because I found out if I send 5,000 records in a second, that doesn't make a good demo because the demo's then done. Because I don't have infinite number of records for some reason. Maybe you have infinite number of records. I don't have infinite records for, doing these things on the fly. There was questions yesterday, why might I use one tech versus the other? And there was a soup of different projects used. And when you use them together all the time, you're like, yeah, you just use them when you use them. This is where you make the decisions, what makes sense for what part. For NiFi, getting things started, instead of writing code, instead of writing something that's maybe too batchy, or doing something you don't have to make those decisions on, how do I get started? If I have a link to something, if I have a URL, I have a file, I have a database connectivity, that's how I get started. That's the first step. It's really easy. And what's nice is it could be any kind of data. I mean, the spectrum of data from a zip file full of XMLs, a binary that contains a Word document, and that you want to grab an Excel table out of and convert it into JSON, then push it to a pulsar topic that gets ingested to Pinot. Anything is your oyster. It doesn't matter what it is. And you start off with, what am I getting? Am I getting a REST endpoint? Get me a REST URL, and I walk through the steps. Is it live transit data? Is it a table? Is it CDC? Is it images? Whatever makes sense for your use case. Air quality is a nice one. And it doesn't matter how weird the data might look like. For this one, I'm grabbing all the air quality readings in the United States. And their REST API is pretty ugly because they only want to give you 100 rows at a time. So I got to keep recalling it by incrementing the page I'm on. And there's like 6,000 pages. So I just create a little loop, grab all the pages, grab those up. But the data format is really bad. Now, I could just decide to take whatever that JSON looks like with all the weird extra stuff and maybe lots of nulls, sparse arrays, and just send it on to the next person, let them have to deal with it, and then maybe that ugly JSON gets saved in Pinot like that. I'm nicer than that. I don't want to send someone some junk-looking data, especially since it's not a lot of work for me. So I can just take the fields I want out and then rebuild it with just the ones I like, and then reconstruct it, enrich it with a couple extra fields, like make sure every data has a timestamp and a unique ID. I don't know why a lot of these sources don't have a timestamp. It makes it very painful for Pinot. It makes it painful for Flink. If you can't give it to me in your own data set and I can't interpret it from some other date columns, I'm going to add my own so at least it has a timestamp when it happened. And then I could do something like push it to Kafka or something else as a new constructed format. It just makes it a lot easier if you're doing something like that. Another thing I've found to be the ultimate way to change your data as it's coming in is something like a query record. This is a unique thing. Let me find a better select. Let's find a good select clause. Yeah, it'll search anywhere within any of the flows I've deployed. Find a nice one. I don't know, too many. So what happens is you could pick, I can grab any fields I want from them, do where clauses, ordering, sorting, and this is a good way to limit the fields you want without having to write any code. And what's cool is I could take XML data or JSON data, syslog data, any format that you want. There's a lot of different ones here. I can grok from a log file, and then the results of that I could use SQL process it, and then output it in another format. I get output it to JSON or Avro or Parquet, and then it's in a good clean format to land somewhere, add a schema to it, push it right to a table or somewhere else. Gives you a lot of options there. Pretty easy to do. It's not rocket science here. This was created by the NSA, which is not rocket scientists. Maybe they have rockets, but they don't have the science there. Pretty easy stuff. Like I said, you start off with REST. Like here, I grab all the bike data, clean it up a little bit, convert it maybe to a different type if I needed to, split it out, add a timestamp, push it on. That's a pretty standard way to do that. Now, is there any questions? No questions? Too easy? Is there other things that would be relevant in this topic? Do you have any questions on what I should do with IoT for, in the back?
Sorry, I wasn't, I missed the first part, but where are you running your Apache NiFi?
I'm running it 2 places. One that's very sad, and you can see that at the top, localhost. I'm running it in literally as just a Java app on the laptop. Sometimes I run it with Docker, but right now I put way too much stuff in my Docker, and Pinot isn't happy. That's probably too many servers to run on a laptop in Docker. I probably should move it to Kubernetes or ask for more memory. I'm running some stuff in the cloud, but that costs money. So I am running NiFi in the public cloud, and this is an alternative designer to the one in NiFi. The unique feature of NiFi is the component you see and the UI are not connected. They are modular. So I know some people have written their own. Cloudera has a new one that just came out. There's one that's the Apache one. And there's also some people code NiFi without a UI because it has a full, everything the UI does is a REST call into the NiFi server to do that coding. So you could code out your entire scripts without having to use the UI if you're someone who doesn't like drag and drop, which kind of crazy, but you can do that. And then when it's actually running, this is the monitored environment running in Kubernetes. So what's unique about this, because NiFi exposes everything via APIs, we can monitor everything going on, and I can decide which ones I want. And in environments like this on Kubernetes, it can monitor every single little bit. So I can monitor every connection between a processor, every file coming in and out, every step, as detailed as you want, and set up alerts. What's cool with this cloud Kubernetes version is I could change versions on the fly. So I could decide that I want to upgrade to the latest NiFi, maybe I'm a couple versions back. It'll automatically deploy that one flow in its own environment. Kind of cool. Easier way to do that. And there's some system metrics you get. And if there was any alerts, they pop up here, and those will get pushed to Prometheus and Grafana and other stuff. I want those pushed back into NiFi, but you know, people do different things. The thing I want to touch real quickly is new version of NiFi could deploy to Lambda or to Azure Functions or Google Cloud Functions as idempotent jobs that are triggered by events. Anything else? It'll probably be in the front, so you'll have to run. Nothing? Very cool. I did have, we do have some stickers and some stuff here, and I wanted to invite people to my friend's booth at Stream Native. They're doing a giveaway for something cool. A what? A thing. It's a device that you have to carry home. Oh, it's an Apple smart device, so that's pretty cool. You could probably hook that up to NiFi and then push that data to Pinot and write your own IoT projects for next year's conference, which would be pretty cool. If there's no more questions, I'll wrap it up early. I don't, otherwise I'm just going to be probably writing an app or trying to fix my Docker environment, which if people want to help, come on up, we'll fix the Docker. No people want to figure out why my Pinot environment has lost one of my things here. No one wants to debug that. Oh, we got a volunteer from the log guys.
Voila, it works.
Good job.
So my question is about collaboration over NiFi. Someone's maybe writing it as code, someone is writing it using the UI.
Yes.
Are they able to collaborate? How does it, what's the interface?
There's a couple of options. Now, it really depends on how you want to do it. Option one is there's a whole permission system built into NiFi, and there's also a version that can be done with Apache Ranger to give you fine-grained control. So if you don't want people to touch your stuff, you can prevent them from touching your stuff. The option is you literally can have two people in the same flow from their own browsers editing pieces. Is that a good idea? No, that was the original way that NSA worked on live projects. Do I recommend that in the case where you're not tracking things that need to change in the next 10 minutes and you all do it on a screen that's this size and there's worries that if someone screws it up, something's landing in the wrong country? You probably don't need that at home. Most people collaborate. There's a version control system, depending on which environment you're using. If you're using the cloud-based one, everyone gets their own environment, and then I'll save a version, and then you could work on a different version. If you're using the pure open source, there's a NiFi registry backed by Git, where you could take out versions, work on them, commit them, and we could see that. What's cool with the NiFi versioning, it versions components. So if I move the component over an inch, that's a version change. So it's very robust if you want to do it that way. I haven't seen too many people pair programming on NiFi because it is kind of easy. I have seen people do it over Zoom, and usually we'll let someone take it over because you're like, I can't figure out what's not working. But again, it's pretty easy to debug in NiFi because I can look at what's in the provenance data. I can also test by resending data if it's still in the buffer. So if I go to provenance and I want to try something again, I could just go to the content if it's recent and replay it. Let me see if we got some more data going here. And that makes it a really, really interesting way to retest data, is to just look at something that's sitting in the provenance and go, let me replay it and run that data again. And then you could step through, because you could stop each component, run it, run one at a time. That's another option. So if I'm in here and I want to see just one record go through, that one's already gone through. Like this one, let me just run it once. And only, one event will happen. And then I could see, okay, there's still the error, look at the error, figure out what I'm going to do. What's kind of cool for this, if you're interested in logging and tracing, is everything that happens, including errors, log events, and just touching the events, can be pushed to another system as entire events with metadata. And we could actually edit that with NiFi, but I could push that to a third-party logging system. I can push it to Kafka, a database, a log file. I think we had a connector for Datadog. There may be some other ones where you could just send all that data to them and they could figure out what they want to do with it, which is kind of cool for logging, tracing, that kind of stuff.
So just a continuation question. Does it make sense to make things modular, and so someone's working on NiFi in their environment and it'll connect to another environment of NiFi?
Yeah, NiFi can communicate to other NiFis through its own protocol, which is either TCP/IP, UDP, or SSL. But I could also communicate to NiFi over, obviously, Kafka, Pulsar, anything that connects them. The nice thing is if I connect between the NiFi instances with the NiFi connectors, it pushes along all of the metadata with it. So once I send something to Kafka, I lose that lineage. Now, if you're in a Cloudera environment, we have Apache Atlas that taps into Kafka, so it continues that lineage on. But in general, in the open source, if you haven't connected all these different projects together, once it gets into Kafka, you lose all that metadata, unless you add those manually as Kafka headers or Pulsar headers and then get them on the other side and reconstruct them, which is pretty rough. That's the reason why people don't do auditing, right? Because I got to do manual work. NiFi does it for me, so I don't have to think about it. It could also be encrypted or turned off for people who have security concerns. Every SSL can be on for everything. Every single step can add additional encryption. All packets can be encrypted. All attributes can be encrypted. And it supports 16 or so encryption things. We are out of time. Thank you for asking really cool questions right at the end. But time to get to your next thing. Thanks a lot. It's been a lot of fun. Hopefully see you next year.